Let's start this worksheet. It is very, very important and my favorite too. A more reactive metal will displace less reactive metal from a solution of its salt. By the way, this reaction is also called displacement reaction. And this displacement reaction is also called redox reaction. All right. This reaction is exothermic. This reaction is exothermic. Now the question is why it is exothermic? What's going on actually in the reaction? So we need to go in little bit detail so that we can understand why this reaction is exothermic. अगर आपको याद हो मैंने कुछ दिन पहले आपको सिलेबस में गिब्स फ्री एनर्जी से रिलेटेड इंफॉर्मेशन शेयर की थी. ये आपका पहला इंफॉर्मेशन है which was delta G naught equals to minus NF E naught cell, right? So अगर E naught cell की वैल्यू इंक्रीज होगी तो ऑब्वियसली delta G becomes more negative. Then delta G naught is negative. Okay, ये मेरा पहला स्टेटमेंट आ गया. एंड इफ डेल्टा जी नॉट इज नेगेटिव इसका मतलब रिएक्शन स्पॉन्टेनियस होगा, रिएक्शन हो जाएगा. मैंने आपको एक एक्सप्रेशन और शो किया था अगर आपको याद हो. डेल्टा जी नॉट इक्वल्स टू डेल्टा एच नॉट माइनस टी डेल्टा एस नॉट. अच्छा आप नोट कीजिए इस पूरे प्रोसेस के अंदर टेम्परेचर, रूम टेम्परेचर प्रेशर लिया जा रहा है तो इसका मतलब टी इज कांस्टेंट. सही है, टी इज कांस्टेंट. और ये जो डेल्टा एस नॉट है ये भी कांस्टेंट है. तो एंट्रोपी क्यों कांस्टेंट है इसको देखो. ये सॉलिड ये भी सॉलिड कैंसिल हो जाएगा एक दूसरे से. ये भी एक्वस कैंसिल हो जाएगा एक दूसरे से. इसका मतलब जितने नंबर ऑफ पार्टिकल्स यहां पर है एग्जैक्ट उतने ही नंबर ऑफ पार्टिकल्स यहां पर भी है. इसलिए इन तमाम रिएक्शंस की जो एंट्रोपी चेंज है वो सेम होगी. तो एंट्रोपी चेंज भी सेम हो गई, टेम्परेचर भी सेम लिया हुआ. इसका मतलब ये पूरा का पूरा फैक्टर कांस्टेंट हो गया. अब नोट करें अगर डेल्टा जी नॉट आपके पास नेगेटिव है फ्रॉम द वेरी फर्स्ट पार्ट तो डेल्टा एच नॉट भी क्या हो जाएगा आपके पास नेगेटिव. सो रिएक्शन एक्सोथर्मिक इस सेंस में होगा. ओके तो हम यहां लिख सकते हैं if delta G naught is negative, if delta H naught is negative, delta H naught is also negative. Hence reaction is exothermic. That's the whole concept behind this minor statement. ठीक है ना. ये दो कॉन्सेप्ट की वजह से रिएक्शन एक्सोथर्मिक हो रहा है. वो कह रहे हैं if the same reaction is set up in an electrochemical cell then instead of an enthalpy change electrical energy is produced and the cell voltage can be measured. यही मैंने आपको इन दोनों में बताई ये बात. You are planned to investigate the reaction of the three different metals. So we are looking for the three different metals with aqueous copper 2 sulfate. You are planned to investigate whether there is a relationship between their cell potential values and their enthalpy changes of reaction. तो मैंने ये आपको रिलेशनशिप डिटरमिन करके दिखाया है. ठीक है ना. Copper 2 sulfate is moderately hazard. Zinc sulfate is corrosive. Iron 2 sulfate is health hazard. Predict how enthalpy change of reaction and E naught cell increases. Give a reason for your prediction. तो ये आपके सामने है पूरी की पूरी रीजन. रीजन ये है कि अगर E naught सेल की वैल्यू हायर होगी आपके पास तो जाहिर सी बात है डेल्टा जी नॉट भी नेगेटिव होगी। अगर डेल्टा जी नॉट नेगेटिव है तो डेल्टा एच नॉट मोर एक्सोथर्मिक होगी। सो हम यहां लिख सकते हैं the higher the value of E naught cell, delta G naught is more negative, reaction is going to be spontaneous, hence delta H naught is also negative. Reaction is exothermic. The first part of the investigation is to determine the enthalpy change for the reaction of the same number of moles of the three powdered metals. So आप note करें same number of moles हैं three powdered metals के. When determining delta HR metals listed above, independent variable means what we change. And technically we are changing metals, which is why I'm going to write types of metals. मेटल्स तो डिफरेंट हैं, उनको हम चेंज कर रहे हैं, लेकिन याद रखिएगा कि उनके नंबर ऑफ मोल्स हमने सेम लिए हैं. डिपेंडेंट वेरिएबल व्हाट वी मेजर्स, एंड ऑब्वियसली मेजर करेंगे हम टेम्परेचर चेंज. ठीक है, क्योंकि डेल्टा एच आर की वैल्यू यानी एंथैल्पी चेंज ऑफ रिएक्शन की वैल्यू मुझे उसी वक्त डिटरमिन कर सकता हूं, मैं उसी वक्त कैलकुलेट कर सकता हूं जब मुझे टेम्परेचर चेंज मालूम हो. So temperature change is going to be the right answer for this part. Okay, let's move on to the next page. You are provided with a sample of powdered metal and 50 cm cube of 0.5 mole per dm cube aqueous copper sulfate. Draw a fully labeled diagram to show how the apparatus should be set up to allow you to determine the increase in temperature of aqueous copper sulfate. So that's a standard enthalpy change of reaction. And you guys have done this thing with me in A1. Let me draw the simple calorimeter experiment. This is your polystyrene cup, or also called plastic cup. Place this plastic cup this is copper sulfate solution. Okay, we need to add thermometer in it. Then we must have a stirrer. This is going to be the lagging between the beaker and the plastic cup. Okay. So examiner is looking for the fully labeled diagram. Let me label this. This one is temperature, stirrer, plastic cup, beaker, lagging, and solution. Stirrer, plastic cup. It is also called polystyrene cup. It doesn't make any difference. then beaker, and this is going to be 50 cm cube of 0.500 molar. Molar means mole per dm cube copper sulfate solution. Okay. State the measurements you would make in your experiment. So first of all, I need to find out the initial temperature. Before experiment. Then final temperature after experiment. And obviously, we need to take certain amount of mass. So mass of metal needs to be measured through electronic balance. Other than eye protection, state one precaution you would take to make sure that the experiment proceeds safely. We know that zinc sulfate is corrosive, so we need to wear chemical resistant gloves or nitrile gloves and also lab coat. Okay. So wear lab coats and chemical resistant glove. Because zinc sulfate is corrosive. All right. Let's move on to the next page. For the reaction of magnesium, calculate the mass of magnesium in gram. You would use so that it is in small excess. You must show your calculation. Okay. So I know the concentration in volume of copper sulfate, which means I can find the moles of copper ions. Moles of copper sulfate and moles of copper ions both are same. Doesn't make any difference. So 50 cm cube into 0.05 divided by 1000. So moles is 0.025. According to the equation, moles of copper ions and moles of magnesium have same ratio. It's given in the equation, by the way. So अगर हमने 0.025 moles determine किए, the moles of magnesium is going to be 0.025. We need to find out the mass of magnesium. So mass of magnesium determine करने के लिए मैं moles of magnesium को multiply कर दूंगा AR of magnesium से, which is 24.3, which is given in the question. So it's going to be 0.608 gram. So mass of magnesium is 0.608 gram. Now in the next part, explain why metal use should be in powdered form rather than in strips. If we have powdered form, then we can have a large surface area, and so it increases the rate of reaction. Powdered form has a large surface area due to which rate of reaction increases. The aqueous solution of copper sulfate and metal mixture should be stirred continuously. Explain why. Is stirring is used for uniform distribution of heat. Stirring the mixture causes uniform distribution of heat. All right. In one experiment, the increase in temperature with excess magnesium powder is 58.5 degrees Celsius. So that's the temperature change. Calculate the enthalpy change for the reaction in kilojoules per mole. Specific heat capacity 4.18 is given. 1 cm cube is always equals to 1 gram. That's okay. Which means 50 cm cube of copper sulfate equals to 50 gram. So first of all, I need to find out the value of delta Q. Equals to mc delta T. M is mass of solution, and mass of solution is 50 cm cube because 1 cm cube equals to 1 gram. So 50 cm cube equals to 50 gram. Specific heat capacity की value is 4.18. Temperature change is 58.5. So the delta Q for this reaction is 12.3 kilojoules. All right. How much moles of copper to sulfate we have? 0.025 moles of copper to sulfate we have. So in this moles, एनर्जी इज 12.3 kilojoules और आप सब जानते हैं कि एंथैल्पी चेंज हमेशा 1 मोल के लिए कैलकुलेट होती है. So when we have 1 mole of copper sulfate, the energy is going to be minus 489 kilojoules per mole. Why are we looking for the sign in your answer? So sign is going to be negative. Why it is negative? Why it is exothermic? Because examiner ने starting में बता दिया था कि this reaction is exothermic. So we need to put negative sign there. Okay. I hope it makes sense to you. So minus 489 is the right answer. Let's move on to the next page. The second part of the investigation involves the determination of the cell potential for the 3 electrochemical cells. Draw a diagram of the apparatus you would use to measure the E0 cell of the magnesium copper cell. Okay. You should include the names of the metals and the names and concentration of the solution you would use. So we need to make magnesium copper cell. That's what we have done in the class. So let me make it again. ये डायग्राम हमने क्लास में भी बनाई ली है. Okay. इलेक्ट्रोड्स को डिप कर दीजिए बीकर में। ओके, एंड वी नो के सोल्यूशन फिल किया हुआ है हम लोगों ने। ये सोल्यूशन हमने फिल कर दिया, इलेक्ट्रोलाइट फिल कर दिया, यहां पर भी इलेक्ट्रोलाइट फिल कर रहे हैं, और ये दोनों हाफ सेल्स को हम कनेक्ट करेंगे यकीनन सॉल्ट ब्रिज के साथ। ये आ गया सॉल्ट ब्रिज हमारा। सो लेट मी, this is going to be the voltage or voltmeter, which is also called potentiometer. Potentiometer and voltmeter is the same thing. This is going to be the copper electrode. This is going to be the copper ions, which has a concentration of 1 mole per dm cube. This is going to be the salt bridge. This is going to be the magnesium electrode. And this is going to be the magnesium ion solution with concentration 1 mole per dm cube. सो हमने नाम शो कर दिए, हमने नाम और कंसंट्रेशन शो कर दिए। दैट्स इट। ओके, explain why the enthalpy change determination and cell potential determination should have carried out at the same temperature as each other. You know, enthalpy change is temperature dependent, so if you change the temperature, value of enthalpy change obviously changes. Also, cell potential is also temperature dependent, because if temperature changes, cell potential value changes. So to get the fair comparison, we need to maintain the temperature so that we can have a values, so that we can compare the results. So if temperature changes, obviously it will change Gibbs free energy, and so E naught cell. In order to get the fair comparison, temperature for both temperature will remain same. ओके, देखो मैं बताता हूं, मैंने बताया आपको यहां पर, ये देखिए, अगर मैं यहां पर टेम्परेचर को चेंज कर दूं, इस टेम्परेचर को चेंज करूं, तो डेल्टा जी की वैल्यू चेंज होगी, डेल्टा जी की वैल्यू चेंज होगी, ई नॉट सेल की वैल्यू भी चेंज होगी। ओके, इस तरह से सोचना है बात। आई होप इट मेक्स सेंस टू यू। लेट्स मूव ऑन टू द नेक्स्ट पार्ट ऑफ द question. Oh my goodness, accepted E naught cell values are shown in the cell reaction. Use your prediction in A, your answer to D, and the data from the table to predict delta enthalpy change of reaction values. See, I have calculated this. I have calculated the value of this half cell or cell equation. It was how much? Minus 489. Let me write it down. -489. सो जैसे जैसे ई नॉट सेल की वैल्यू कम होगी, एंथैल्पी चेंज ऑफ रिएक्शन की वैल्यू भी लेस नेगेटिव होगी. दैट इंडिकेट्स कि एग्जामिनर इज लुकिंग फॉर द प्रेडिक्टेड वैल्यू. ओके, so you can predict any value that represents the trend. So it's -350 and it's -200. So as E naught cell value decreases, enthalpy change of reaction becomes less exothermic. So that was the relationship we have given in part A. Okay. So that's the end of this question. Let's move on to the next question. Titration using ethylene diamine tetraacetic acid, that is EDTA, can be used to determine the concentration of metalline in solution, such as zinc ions. A solution of EDTA is usually prepared from the hydrated disodium salt. The anion of EDTA is H2Y2 minus, where Y represents the organic part of the ion. The equation for the reaction between zinc ions and EDTA is shown. The indicator of the reaction is solochrome black, which changes the color at the endpoint from purple to blue. The indicator only works at pH 10. So the buffer solution is added to this metalline solution, maintain the pH. Explain why the pH would change during the titration if the buffer were not present. If the buffer was not present, obviously hydrogen ion का amount increase होगा. जब hydrogen ion का amount increase होगा, तो pH definitely decrease होगी, because hydrogen ion की formation हो रही है, hydrogen ion increase हो रहे हैं, pH is inversely proportional to hydrogen ions. So if concentration of hydrogen ion increases, this pH value decreases. So let me write it down this. During the reaction, concentration of hydrogen ion increases, so pH value decreases. Okay. You are to plan a titration experiment to determine the concentration of zinc ions in a solution of zinc sulfate of concentration approximately 0.1 mole per dm cube. You are provided with a 20 gram of hydrated EDTA with an MR of 372.2, zinc sulfate of concentration 0.1, buffer solution of pH 10, and solochrome black indicator. Name 3 pieces of volumetric apparatus that would use with their capacities in cm cube. Obviously, हम titration का experiment कर रहे हैं, right? We are doing the titration experiment, and in titration experiment, we need it with 50 cm cube. We need pipette of 25 cm cube, and obviously I need volumetric flask. Because मैंने 20 ग्राम को यूज करके सोल्यूशन प्रिपेयर करना है, और मैं तकरीबन 250 cm क्यूब वॉल्यूम यूज करूंगा उसका साइज. So 250 cm cube of volumetric flask is used to make the solution. Okay. Let's move on to the next part of the question. Calculate the mass of hydrated disodium EDTA that would be required for the preparation of a standard solution of concentration 0.1 mole per dm cube using the apparatus you have specified in 1. Apparatus specified in 1. So मैंने 1 में कौन सा apparatus specify किया? 250 cm cube of volumetric flask. तो मुझे इसके लिए solution prepare करना है. Okay. So मैं सबसे पहले moles hydrated EDTA salt. Concentration is given 0.1 mole per dm cube. Volume of volumetric flask is 250 cm cube divided by 1000. So I'll get 0.025 moles. Okay. Now let me calculate the mass of hydrated EDTA. The moles is 0.025 and the MR of hydrated EDTA is already given, which is 372.2 gram, right? So multiply करते हैं इसको 372.2 से. So you will get 9.31 gram. So 9.31 is the right answer. So technically हमें कितना मास दिया हुआ था 20 ग्राम, हम उसमें से कितना यूज कर रहे हैं 9.31 ग्राम. सही है. Now the next part of the question is describe how you would prepare this standard solution for use in your titration. Okay. And describe करने के लिए कह रहे हैं. So मैं सबसे पहला पॉइंट क्या लिखूंगा? At 9.31 gram of hydrated EDTA in 100 cm cube beaker, dissolve this solid by adding distilled water. Transfer this solution into a 250 cm cube volumetric flask. Rinse the beaker with distilled water. And transfer this washing into the flask. Top up the solution with distilled water until 250 cm cube mark reach. Stopper the flask and shake well. Okay. I hope it makes sense to you. After you have performed a rough titration, how would you ensure that your next titration is accurate? Accuracy belongs to reliability of the experiment. And in order to get the reliable results, I believe We need to get the end point. Yeah, that's the possible answer. Add the solution until end point is reached. Until end point is reached. Let me think. Let me give me few minutes. I think that's the best answer we can have. Yeah, that's the best answer. How would you ensure that your titration results is reliable? Reliability of the experiment belongs to the reliability means accuracy of the experiment, और accuracy उस वक्त आएगी जब तुम multiple readings लोगे और multiple readings से average. So take the multiple readings. Until concordant readings of 0.1 cm cube obtained. I hope आपको ये याद हो कि जब भी आप टाइट्रेशन करते थे A1 केमिस्ट्री में आप 0.1 cm cube की concordant readings डिटरमिन करते थे हमेशा. Okay. Let's move on to the next page. My goodness. The term hard water is used to describe water containing dissolved metal, calcium ion, and magnesium ion. Both of these metal ions reacts with EDTA. By the way, these metal ions and EDTA have same molar ratio. Two moles of EDTA है तो 2 moles of ions भी हैं. In an experiment, to determine the concentration of each of these metal ions, two separate titrations with EDTA needs to be performed. In titration 1, 25 cm cube of sample of hard water. That's very, very crucial statement. So we are using 25 cm cube of hard water, which is reacted with 0.01 mole per dm cube EDTA solution. In another titration 2, another 25 cm cube of the same hard water is used. लेकिन उसको यूज करने से पहले उन्होंने क्या किया, 2 मोल पर डीएम क्यूब NaOH से इसको ट्रीट करवा के सारे के सारे मैग्नीशियम आयंस को प्रेसिपिटेट कर दिया है एज मैग्नीशियम हाइड्रोक्साइड. और आपके पास अब सॉल्यूशन में मैग्नीशियम आयंस नहीं रहे, सिर्फ आपके पास डिसॉल्व कैल्शियम आयंस हैं. ये डिसॉल्व कैल्शियम आयंस EDTA के साथ रिएक्शन करेंगे यूजिंग सोलोक्रोम इंडिकेटर. The following information gives some of the hazards associated with the chemical used in the procedure. Sodium hydroxide is corrosive, and solochrome black is flammable and has health hazard. Identify one hazard that must be considered when planning the experiment and describe a precaution other than eye protection should be taken to keep this risk from this hazard to a minimum. जाहिर सी बात है गॉगल्स तो नहीं पहनने, उनके अलावा बात करते हैं. और क्योंकि सोडियम हाइड्रोक्साइड कोरोसिव होता है, यहाँ लिख देते हैं हम, sodium hydroxide is corrosive and we need to wear chemical resistant gloves, also called nitrile gloves. Okay. Let's move on to the next page. Results obtained from this experiment are shown. This is titer 1. ये titer 1 मुझे titration 1 की वजह से मिला है, ठीक है? ये titration 1 था जिसमें कैल्शियम मैग्नीशियम आयन दोनों इन्वॉल्व थे. ये टाइटर 2 है जिसमें सिर्फ डिसॉल्व कैल्शियम आयन है. सही. Use the result of the titrations to determine the concentration of calcium and magnesium ion in the hard water. Okay. So first of all, let's talk about titration 1. First of all, we need to find the moles of EDTA. Volume is given 22.7. Concentration is already given 0.01. When you divide it by 1000, you will get 2.27 into 10 to the power minus 4 moles. Okay. We know that molar ratio of magnesium and calcium ion is equals to molar ratio of EDTA, which means both of them has 1:1 का ratio. All right. So अगर आपने EDTA के 2.27 into 10 to the power minus 4 moles calculate किए हैं, so moles of magnesium ion and calcium ion आपके पास आ जाएंगे same, that is 2.27 into 10 to the power minus 4 moles. जाहिर सी बात है ये दोनों के दोनों आयंस हार्ड वाटर के अंदर थे और हार्ड वाटर हमने लिया था 25 cm क्यूब. इसका मतलब ये जो मोल्स हैं ये 25 cm क्यूब में हार्ड वाटर बोले या मैग्नीशियम कैल्शियम आयन का सॉल्यूशन बोले, इट डजंट मेक एनी डिफरेंस. सो that is 2.27 into 10 to the power minus 4 moles. To get the concentration 1000 cm cube, the concentration of magnesium and calcium ion in hard water is 9.08 into 10 to the power minus 3 mole per dm cube. Okay, that's the procedure of the titration 1. Let's talk about the titration 2 things. Now in titration 2, we have only dissolved calcium ions. We know the concentration, we know the volume, we can find the moles of EDTA. 16.6 into 0.01 divided by 1000. So I'll get how much moles? 1.66 into 10 to the power minus 4 moles. Now in titration 2, moles of EDTA and moles of calcium ion are same because of 1:1 ratio. अगर आपने 1.66 इंटू 10⁻⁻⁴ मोल्स लिया है, मोल्स ऑफ कैल्शियम आयन यहां से सेम हो जाएंगे आपके पास, दैट इज 1.66 इंटू 10⁻⁻⁴ मोल्स। ये जो मोल्स ऑफ कैल्शियम आयन है, ये 25 cm³ ऑफ हॉट वाटर के अंदर लिए थे आपने। कंटेन, बल्कि ये हार्ड वाटर भी नहीं था, ये अब सिर्फ कैल्शियम आयन था, क्योंकि मैग्नीशियम हाइड्रोक्साइड प्रेसिपिटेट हो चुका है। So 25 cm³ of calcium ion has 1.66 into 10⁻⁻⁴ molar -4 moles। सो अगर मैं इसको कंसंट्रेशन में कन्वर्ट करूंगा तो 1000 cm³ से कंपेयर हो जाएगा। सो concentration of calcium ion is going to be 6.04 into 10 to the power, बल्कि 6.66, sorry, 6.64 into 10 to the power minus 3 mole per dm cube है। So I've got the concentration of calcium ion, which is 6.64 into 10 to the power minus 3 molar. I need to find out the concentration of magnesium ion. So हम क्या करते हैं, concentration of magnesium ion determine करने के लिए 9.08 into 10 to the power minus 3 को subtract कर देते हैं 6.64 into 10 to the power minus 3 से। So इस तरह से मेरे पास concentration आ जाएगी 2.44 into 10 to the power minus 3 mole per dm cube। आप नोट कर रहे हो, ये कंसंट्रेशन थी कैल्शियम मैग्नीशियम आयन की। कैल्शियम आयन आपने डिटरमाइन कर लिया था, दोनों को सब्ट्रैक्ट करूंगा तो मुझे मैग्नीशियम आयन की कंसंट्रेशन मिल जाएगी, एंड दैट्स व्हाट आई हैव डिड। सो ये हो जाएगा 2.44 into 10 to the power minus 3 mole per dm cube, and that's the end of this question also. I hope it makes sense to you. रिकॉर्डिंग्स में शेयर कर लूंगा आप लोगों के साथ। बहुत शुक्रिया आप लोगों का। आपकी अगली क्लास भी ऑनलाइन होगी इंशाल्लाह ताला वेडनेसडे वाले दिन, उसमें इसके बाद जो भी वर्कशीट है वो अटेम्प्ट करेंगे। ओके, थैंक यू।